MacMaths, let's do some maths today. Statistics. Okay, so this is the last lesson of chapter 2, and the last section is coding. I'm going to explain coding to you, what it is, how we do it, and so on, and the little formula, the coding formula to look at. Okay, and what's the point of it really? Okay, so I'm going to go over that. I'm also going to go over some questions, one from the start, middle, and end of exercise 2F. So there's going to be some question support here. It's not going to take me very long to explain. It's very simple, coding. Okay, here we go. To explain it, what I've done is I did a lesson on position and spread, on medians and quartiles and percentiles. That was exercise 2C, and on the lesson support of that, question 1 was very simple. It had 16 numbers. I've just done 1, 2, 3, 4, 5 in here, but it had 16 numbers, and they're all like this. They were pressures, like air pressures, and these are typical of this hectopascals, whatever that is. I don't know what it is. Okay, but you had these numbers, and you had to find the median and the quartiles. In other words, and I did this question as part of the lesson support, and you had to put all the numbers to find the median. Of course, you've got to put them all in order, and there were 16 of them. So when I did that question for you, I did say, use your common sense here. Rather than, when you put them in order, rather than, write down 1,000 and, what's the smallest one there, 1,016, just write down 16, and then 18, and then, 22 and 24 and 28. Just take the last 2 digits, because all this, and then when you find the median here is 22 because it's the middle number. Remember, it's not really 22, it's 1,022. Okay, so remember me doing that, and I remember did that. Well, wasn't sort of thinking about it at the time, but what I was actually doing was coding. Okay, so coding, statistics is mathematicians are dealing with statistics, and they're collecting in numbers, and sometimes those numbers can be big or even bigger than this, and they've got to type all of those into a calculator or into a spreadsheet to find things like the mean and the median and the standard deviation and so on, which we've been doing. So it's a bit of a faff typing all these in. So if we could code our data, apply a formula to them to make them smaller, like I did here, that formula was simple, just take off 1,000. Okay, put those numbers in, get answers then. It's been easier to get those answers. We can just uncode them at the end to get our mean and standard deviation. And that's what coding is. Okay, so let's have a look. I'm going to pick a very sort of simple example that I just make up myself now off the top of my head. So this is my example. I'm just going to take 3 numbers and code them. Okay, so I'll just go, let's say, 106, 108, and 110. There you go. So 3 numbers, 106, 108, 110. You can see here that the mean of those, okay, is 108. Okay, add them all together and divide by how many there are, and it would be 108 because they're symmetrical either side of that. Okay, it would be the median as well. I'm not going to work out the standard deviation, so I'm just going to do any measure of spread. Okay, how spread out they are, and I'll do the range for this example. So I'll just do the range, and that's effectively, instead of doing the standard deviation, and they're spread out by 4, aren't they? Okay, from 106, so the range is 4, from 106 to 110. Okay, now let's think about how we could code them. Okay, to make those numbers smaller, we could do 2 things. Remember, we tend to call these variables x, don't we? They refer to x, and then x bar for the mean, and so on. So coding, they give it a different letter. So they say, right, y is the coded figure. So we're going to change all these to a y number, and we're going to make them smaller. What could we do to make them smaller? Well, we could take x and we could take away 6, couldn't we? We could make them smaller by taking off 6 from each one of them. Okay, if we did that, we would then have 100, 102, and 104. Okay, now if you look at that, what has that done to the mean? Okay, well, it affects the mean because taking off 6, okay, it has moved the mean down by 6 as well. You can see that, okay, so it's moved it down, so it affects the mean. But this is the spread of the original ones from 106 to 110, and when we move that down, or even if we decided to add a number to make it easier to calculate, if we move it down or up, you can see it doesn't affect the spread at all, does it? The spread stays, although the numbers have been moved down. So this doesn't affect the spread, okay? So it wouldn't affect that, taking 6 off all of those would not affect the standard deviation, because the standard deviation is a measure of how spread out the data is, isn't it? Connected to the mean, but it's a measure of how spread out the data is. And the data there, even though we've taken off 6, okay, is still, you know, is still spread out, you know, the same amount. I've just thought actually for this, what would have been better, wouldn't it? What a muppet here. If I said, you know, take off, you know, 100, okay? If I take off 100, I've got 6, 8 and 10, haven't I? Oh, that's even better. All right, so 6, 8 and 10 now. And then the mean would be 8, 100 low, but you can see they're still spread out 4, aren't they, from 6 to 10. Okay. Another thing we could do to make the numbers smaller is we could divide them by a number, couldn't we? So we could divide them, all of these, by 2. Okay. And if we did that, we would have 3, 4 and 5. Okay. Now again, that's affected the mean of those, hasn't it? Because it's halved all the numbers, so it's halved the mean. Okay. It has now affected the spread, hasn't it? Because if you look at the spread now is only, it's halved the numbers, so they've all halved in size, whatever, so it's shrunk the range as well by 2. So if you divide it by any number, it has that same effect on the spread. So to get it back to the original spread, we would have to times it by 2. Okay, so this is the coding formula that mathematicians tend to use. Okay, they tend to use, oh sorry, that's Nanny phoning. They tend to use, I'll let my wife get that, x minus a over b. That's the one that in the book it tells you to use. Hang on a minute. There you go, she's answered it. I might edit that out if I can work out how to do that on iFilm. So where you work out a or b, you don't have to. You know, you can just take a number off and just have an a number, or you could divide it by b. And have them made even smaller as well by that effect. So those two numbers. Remember, if you then change these to y, okay, so if I apply, let's just do that. Let's apply that y. If we start with these again and say, right, so I'm going to apply a formula where y is equal to x minus 100 divided by 2. Now we've got a value for y, and y would be, take away 100, so 6 divided by 2 was 3, it was 4, and it was 5, wouldn't it? Okay, so this is x, this is y. Now the mean of y, okay, now is 4. Okay, and the spread, or the range, is from 3 to 5, which is 2. Okay, so now if we wanted to find, if we're given the mean or we've worked out the mean of the coded one, okay, so if y equals this, then y bar is equal to x bar minus 100 over 2. Okay, so remember that if the numbers are moved down and then divided, the mean would be moved down and then divided. So to change it back, we simply do the reverse of this, and it's just rearranging, isn't it? So the first thing, we times by 2 and add 100. So that, if we times by 2, which is 8, add 100, we get 108. Okay. But remember, the range is only affected, moving it up or down does not affect the range. So the range is only affected by this bottom number. Okay. So in other words, if we wanted the range back, all we need to do is look at the range that we've got a range of y is 2, and then look at what this is here, and we do the reverse of this, and we times it by 2, okay, to get the range, which would be 4, and give us it here. And so that's what we do to get the standard deviation. If this was the standard deviation, if it had a standard deviation for x of 4, then the standard deviation of y, you know, we would just sort of multiply it by 2, okay? All right. Okay, let's just do some questions. And it makes more sense when we do some questions because I just made that up off the top of my head. I can tell I was just waffling, but it'll all make some sense when I do the questions. Okay, so I did write some out. I thought I'd do question 1 because it's ridiculously easy, and then one from the middle because it says it's a problem, question 5, and then one from the end, question 8, about a teacher doing some standardization. So this is exercise 2F. Okay. The first one, question 1, it gives you some numbers, so 110, 90, 50, 80, 30, 70 and 60. Okay. And it says code using y equals x over 10. So there's no, it's not move them up or down, it's just divided by 10. Okay. And then it says find the mean of the code. Now it says the mean of the coded, it doesn't put that x bar of the coded. In other words, I shouldn't have really done that. In the book it just says the mean of coded, so let's just change that, mean of coded. In other words, what it's saying is find out y bar, okay, and then it says find out x bar. In other words, the original data, the mean of the original data. Okay, so if we code this data using this formula, if x is equal to those numbers, then y, so this is question 1, y is these numbers divided by 10. So that's going to be 11, 9, 5, 8, 30, so 3, 7 and 6. Okay, and it's, so we've coded them now, okay, and we want to find the mean of those coded numbers. That was the part B. That was A, part B. The mean of those coded, well, it's all of that added together, and they add together to give you 49. And there's 1, 2, 3, 4, 5, 6, 7, or 7 numbers. So divide by 7, so it's 7. Okay, so 49 divided by 7. And C, okay, what's the coding formula? So the coding formula, what do we do to those numbers? We divide it by 10. So if y equals x divided by 10, then y bar is equal to x bar divided by 10. Now we've got y bar, we've got the mean of the coded numbers is 7. So 7 is equal to x bar over 10. So times both sides by 10. So it makes sense, doesn't it? The mean of those original numbers would be 70. Okay, so we just reverse that there. Okay. Now normally when I'm doing the questions I do them in red, don't I? So I don't know why I'm using blue. I'm going to switch back to red. Okay. So that was a really, really simple one, wasn't it? Now question 5, it's telling me that, let's just do it at this a little bit nicer. Sorry, I forgot to get this nice for you. Normally do that. Go along there like that. Oops, no, poo. There like that. Okay, and this is the lifespan of 70 light bulbs in a table, and it says that they're coded, y is coded using that formula, so take away 1, don't know why, and then divide by 20 to make those numbers smaller to put into your calculator. Okay, so let's do this one then. So of course when we're doing this, you know, if we're finding the mean and the standard deviation, it's what we're really talking about is the estimated mean and the estimated standard deviation, aren't we? So we pretend that these 3 bulbs lasted the midpoint of the group. The midpoint of this group is 21, and what are we going to do? The y numbers, okay, so the x numbers would be 21, wouldn't it? The midpoint of the group. So the y numbers, we're going to take off 1 and divide by 20. So 21 is the midpoint, take away 1 is 20, divided by 20, the first one is 1, and the frequency is 3. Okay, so this becomes 1 and the frequency is 3. This group, applying this coding to the midpoint, so 23, take away 1 is 22, divided by 20 is going to be 1.1. I can see where this is going, is 12, and then it's 1.2 and 40, 1.3 and 10, and the last one, I'll just do that one, so 28 is 29, 29, take away 1 is 28, 28 divided by 20 is 1.4, you see, okay, it's 5. So this now, what we've done effectively is we've changed the midpoint by this coding formula. So that means instead of putting in 21 and 23 and 25 into my table, I'm just putting in 1, 1.1, 1. Now you may say that's not a lot easier. Yeah, I agree with you there actually. But it's just an example, isn't it? And cancel. So menu, yeah, let's go 6 and 1, and I hope it's got a free table. So it's yeah, it's just an example, but in in real life there will be coding to make the numbers simpler. So let's do this anyway. Let's do this table. So here for our x, which is really y, isn't it? So we're going to go 1 equals 1.1 equals 1.2 equals 1.3 1.4 equals, okay, and then we're going to put in frequency. And what have we got? We've got 3 equals 12 equals 40 equals 10 equals and 5 equals. So we'll put those in, press our options, 3, and it gives us the mean. So it says x bar, but actually we know we've just calculated out y bar, which is 1.20, okay, and the standard deviation of x, so really the standard deviation of y is that 0.0, and I'll go to 3 decimal places to make it a bit more accurate, it's 0.088, okay. Alright, so I've got that data from there, oh, hang on, let me just get back because it just irritates me. There we go, back to normal now. So it says find the mean of the coded data. Well, we've done that, we've got 1.2, okay. It wants the mean of the actual data, okay, so we've got to change it back. So remember the coding formula, so we've done A and we've got 1.2. So for part B, remember that the coding is y minus what? The coding is y equals x minus 1 over 20. That's what we did, okay? So we've got to, if y is 1.2, so remember that y bar then is equal to x bar minus 1 over 20. The same effect would have on the mean. So what we've got to do to that number is if we put in 1.2 there, we've got to times it by 20 and then add 1, reversing it, isn't it? So x bar times it by 20, so 1.2, 2 times 20, add 1 is 26. Okay, is that right? Can you see that on there? Yeah. Okay. And I don't think that's right actually. I don't think I've done that right. What's the code? X minus 1 times 20. So 1.2 times by 20 and then add 1 is 25. I don't know where I got 26 from. It's 25. Sorry. That's right. X bar is 25. Sorry, I'm making a right mess. I guess I might edit it, this one. Okay, and part C, an estimate for the standard deviation. Now we wrote the standard deviation. Remember, moving it up or down, it doesn't affect it. Okay, but this divided by 20 affects the standard deviation. So all we've got to do is times that by 20. So 0.88 to change it, 0.088 times by 20. Okay, we'll change it back to the standard deviation. So would be 1.76. Okay, and that is right, the right answer. Okay, so only this division, okay, affects the standard deviation. Okay, moving it up and down keeps the spread the same. Okay, this adjustment. All right. Okay, so sorry about, you know, like I said, I'm better at mechanics than statistics. I can do it all, but I'm not as fluent as, so I've not taught it before. This is my first run through as well as yours. Okay. And but I'm getting better. I'll be better at teaching it after doing all of these lessons, because I am teaching it next year. Okay. And I did one of the harder ones. It says this is a problem and an exam question. So is it the last one? I think there might be one more. Oh yeah, the last one was even a little bit easier than this one. So I thought this was the hardest of them when I looked back. So here we go. So a teacher has standardised, has got some scores in, and has standardised the scores by adding 12 and taking off 20%. Okay, so it's got some scores X. I'm going to change that in a minute. Original marks is M, and standardised marks is T. Okay, so the standardised marks T, okay, is equal to, well, she's got the original mark M and she's added 12 to it first. So she's added 12 marks to it, and then she's taken off 20%. Okay, if you take off 20%, it goes from 100%. What's the multiplier for that? 100% down to 80%. So that's the same, isn't it, as timesing by 0.8. Okay, so that is the formula. So the formula is 0.8 is 8/10, so it's 8/10 of M plus 12, isn't it? Okay, and the first question says, part A says, give the coding formula. Now, if you remember in the book, it likes the coding formula to be this x minus a all over b, doesn't it? It's like that, so plus or minus a number there and then divided by. Okay. If you remember, when you remember, Mr. Orm taught us that KFC, didn't it? When you're dividing by a number, so you're dividing by a fraction. If you divide by 3/4, you invert and multiply, don't you? So dividing by 3/4 is the same as timesing by 4/3. So that means the same as timesing by 4/3 is the same as dividing by 3/4. So timesing by 8/10 is the same as dividing by 10/8. So T is equal to M plus 12 dividing by 10/8, invert and multiplied. So it's the reverse of that, 10/8. And 10/8, 10 divided by 8 is 1.25. Okay, there you go. So in other words, timesing by 0.8 is the same as dividing by 1.25, using that basic KFC keep flip change, isn't it, for division, for fraction. Okay, so now we've changed it into this form of coding, and that's what the teacher's done. She's taken the marks, she's added 12, and she's divided by 1.25. That's the same as finding 80% of something. Okay. Okay, so now it's given you some information about this. So it's giving you some summary information. Let's just move that up. TM. So can you remember that? So T is equal to M plus. Oh, what did she do? She added 12 and found 80 divided by 1.25. So that's the answer to the first part of the A, the coding one. Okay, I think on the exam actually, if you wrote t is equal to m plus 12, make sure you put it and did that. Okay, I think you'd probably get the marks for it. I don't know, but I think in the back it's changed it into that if I remember. Okay, part B starts to give you some summary information. It tells you that n is 28. The mean of the coded data, so t bar, is 52.8, and I want to do this question because it gives you this summary data, this capital S, and I've talked about it before but it hasn't cropped up in a question yet. Okay, so STT is equal to 7.3. We'll talk about what that means in a minute, and it wants you to calculate the mean and the standard deviation of the original number. Okay, so n means there's 28 numbers. The mean of the original number, the mean of the coded data is 52.8. So if we go, first of all, the mean of the original data, if we go t is equal to m plus 12 over 1.25, then that is also true, isn't it? So whatever we do to that data, it does exactly the same to the mean. So if we want to replace that mean, we know that that is 52.8. We've got to times both sides by 1.25. Is that, isn't it? And then take 12 off both sides. So 52.8 times 1.25. We've got to work out that, and then we've got to take off 12. And that is our mean. So let's do that. So 52.8 times 1.25 equals, and then take off the 12, and that gives us 54. Okay. So we've done that first part. Now we just want the standard deviation, don't we? Okay. Now, first of all, can you see the TT here? That's the summary data for T, not for the original marks, for the coded. Now, that capital S, you've got to learn this, and I had to learn it, STT. It's that, what that gives you is it gives you that the sum of x minus x bar all squared. It gives you that. It's the original, it comes from the original formula for finding the standard deviation. Okay, and the variance, which is that square, the variance is that over n, and the standard deviation is the square root of all of that. Okay, so that's what that figure is here, that 7.3. So all we need to do with that then, okay, is divide by n, okay, and square root. So therefore the standard deviation of t is equal to the square root of that summary data. So learn what that means. It's that formula. It's almost the standard deviation over 28. Okay, so it's the square root of, when you're given that, it's really handy actually. Sometimes they just give you that sum, the sum of x squared, so you've got to work out the mean squared and do more. But if they give you that, they've almost given it to you. You've only got to divide that by 28 and then square root to get the get the standard deviation. Okay, so let's do that. So 73 divided by 28 is equal to, I should have put the square root in first, square root answer is equal to 1.61. I'm just nervous about that. I don't think that's what I got before. I've written that down. 7 points. Square root of. Let's just do that again. Square root of 7.3 over 28. Oh, I don't get that at all. That looks better. So is equal to 0.51. Could cut out that pause. Okay. So I don't know what I did before. So the square root of 7.3 divided by 28 is 0.51. So that is the standard deviation of the coded data. And remember that the standard deviation is a measure of spread, how spread out it is. Okay, that plus 12 does not affect the standard deviation like it doesn't affect the mean, but dividing it by 1.25 does, so we've got to times that by 1.25. So when we times that by 1.25, okay, it takes us back to that, the standard deviation of the original marks. Okay, so 0.51 times 1.25 is equal to 0.6375, so 0.64. That's the standard deviation. Okay, and that is right. So we've got the mean and the standard deviation, and that's from that. Okay. I know I sort of bundled my way through that one, and there was a few pauses and I made a few mistakes, typed the wrong things into the calculator, but you know, that's life, isn't it? You know, as long as we know what we're doing and we're getting there, that's okay. Alright. Okay, all good. So have a go at those questions, fill in the gaps, get used to this this guy here, this summary information. So remember what that means. That's summary information there. It gives you all of that. Gives you all of that. Okay? And that comes from that original formula for the standard deviation, but we don't use that formula so much because there's too much work to do. There's a simpler way of doing it, squaring all the values and so on. Okay. Right, I'm going to stop there.